May 2008, time zone 1, paper 1, question 11. Okay, we're going to consider these numbers and the sets n, the natural numbers, z, which means integers, q, which means the rational numbers, and r, which means all the real numbers. Complete the table by placing a tick in the correct box. Okay, so natural numbers. 2 is a natural number. Okay. Oh, I need to write it on. 2 is a natural number because the natural numbers are the counting numbers. So they go 0, 1, 2, 3, 4. Okay. And so on. So that's a natural number. These two are not. So it says put a cross if not. So not a natural number, not a natural number. The integers z, quite similar, except we basically have like -3, -2, -1, 0, 1, 2, 3. In other words, the integers can be positive or negative, whereas the natural numbers are only positive. So, but again, they have to be whole numbers. So that's an integer, that is not, that is not. Oops. Okay. Rational numbers, numbers which could be written as a fraction. 2 could be written 2/1. That is a rational number. Okay. This clearly could be written as a fraction because it is. And the square root of 3 is going to give us, let's just do it on here. Okay, so, oh, why isn't this working so well? Second square root of 3. That gives us a decimal that doesn't terminate, it keeps going, and it doesn't repeat itself. It just keeps generating different numbers. Okay, so the square root of 3 is not rational. But all these numbers are real. Okay, so real numbers is just anything that you could put onto a number line. So if you had a number line with 0, 1, 2, -1, -2, anything that you could put on this number line, so 1.7 or something, that goes there. And that's our square root of 3. Our 2 just goes there. And our -2/3 would go about there. So if you can put it on a number line, it is real. Okay. Totally separate question, really, this one. We're going to draw a mapping diagram. A mapping diagram consists of the elements of the domain, which are given, so -2, 2, and 3. And then over here, we're going to put our elements of the range. Okay, so what we need to do is put these separate domains into our function. So we're going to do 2 lots of -2 squared minus 3 times -2. Okay, so that gives us 14. We can put that in our range here. Try with some other numbers. So try 2 instead of -2. I can just edit what I've got already. Come on, why is this not? There we go. Second. Enter. Go back and just take these negative signs out. So delete that negative sign. Delete that negative sign. Oh. Okay, so we've put 2 into our function. We get 2. And if I put 3 into my function, so again, just go back and change the 2's for 3's this time. Okay, so these are the things that I put in to my function. We get 9. So my mapping diagram just is to have arrows that go from the domain across to the range. The range of the function f is just those numbers, so I'm going to put them in order. We've got 2, 9 and 14. That's the range of that function.